Welcome to this Aim High Live. This one is about, is water wet? Yeah, that's the big question of the day. What do you guys think? Just to begin with, let's just jump straight into the wetness of it all. Is water wet? Yes or no? Feels pretty wet. Yeah, if this is your first time here, then thanks for coming. This is an Aim High Live, so you can ask questions whenever you want. If you are watching on Facebook, then you won't see anyone else's comments and questions and stuff. So go here if you want to see what everyone is saying, because most of the chat is not coming from Facebook. Same with YouTube, actually. I'd recommend watching on here. And also, if you go here, you can see all the other lessons that are coming up, because there are going to be loads of other ones coming up after this. In fact, I think there's a good one on this evening. I'm going to say a quick hello to everyone, because there's loads of people saying hi in the chat. Hi, Rapper Singh, Leonardo. The Real Joe is saying hi, everyone. Kieran's here. Angel is here. Posy Joe's here. Hi, everyone. Thanks. Nihal's here. Hi, guys. Thanks for coming back. Posy Joe's Wi-Fi is dead. Yeah, I'm here. I'm on. It's happening. This is going ahead. Okay, so first question. Hi, Rebecca. Hi, LDBR. And yes, right. So, what do you think? Is it wet or not? Is water wet? Is question number one. I don't know if that's the point of the whole live, but I'm just going to ask you guys what you think. And just tell me whilst I quickly grab something. What's the date today? It's the 13th, right? Okay, I'm going to grab this for later. This is what's coming up next week. Looks so good. I'm gonna just quickly show you what's coming up in a mo. But before I do, let me actually go back to what I'm supposed to be doing, which is water wet? Good back. Is water wet? Okay, Maddie says water seems wet. Bailey's saying that water can't really get wet. Pretty sure. The Real Joe's saying water is wet. And Maddie's saying water seems wet. That's the thing. It's a bit difficult to say, isn't it? Okay, and then Rebecca's saying it's not wet until something touches it. Right, okay, so that's what we're going to answer today. We're going to answer, is water wet? And we're going to talk about all the stuff that goes around that. But first, I want you guys to answer this question, which is that, okay, so, right, we can all see that this is a stew, right? That's a stew, and this is a stir fry. And obviously, these come from different parts of the world. Why is it, do you think, that stir fries developed in kind of... like China and the kind of the far east of Asia, and why is it that stews developed in like Northern Europe? What's going on? Why is this? And it's kind of got something to do with water. Stir fry, stew. Why did these different foods develop in different parts of the world? I'm making you hungry. I got this. You know how Wikipedia doesn't allow you to put on like. If like when you edit Wikipedia and you're doing photographs, you can't put on like photographs that have had any editing done. So you know how if you search stew on Google, you'll get loads of like really delicious looking stews that have been like well lit. I can't believe that it is a thing that is like food photographers who go around like lighting food and getting it perfect, but it is. Anyway, this picture of a stew that I found on Wikipedia is just like. No editing, no gloss. It's just like this is the real deal. No one's trying to trick you into thinking it's anything that it isn't. Unlike this, which you can see has been quite well lit. This stir fry. Anyway, yes. So while people are answering the question of what do you think, why did stews develop in kind of like Northern Europe, where stir fries developed in China, and this has got something to do with water. While people are asking that question. Answering that question, sorry. I will quickly just say hello again to anyone who's coming late. So yeah, for those who are coming late, thanks for coming. This is an Aim High Live. You can ask questions whenever you want. There are loads of these going on from loads of different people. I'm doing the science ones, sometimes a bit of maths, sometimes a bit of politics, cheeky politics every now and then, but mainly science. And yeah, do get involved. Go to the website to see like the full calendar of everything, because you can only see, if you're watching on some of my pages, you'll only see mine there. Okay, so what do people think? People are saying maybe water scarcity. Jacinta's saying maybe water quality explains why we have stews in Northern Europe and stir fries in China. LDBR is saying that they haven't had lunch yet. Mate, you got to get some lunch in, otherwise this one's going to make you hungry. Okay, so Kieran is talking about different foods developing in different environments depending on so the different foods develop based on the environment. So in Japan there's a large amount of fish, and so that was part of why sushi was developed. Okay, so there's a lot of people talking about amounts of water. It's not about amounts of water so much. It's more about the wood. Think about the kind of wood that is native to Northern Europe. What you've got is big, thick, slow-growing trees where the trunks, when you cut them down, are heavy and wet. They're full of water. They're very watery trunks. Whereas in China, a lot of the vegetation is much kind of thinner, drier wood. So it is to do with availability of water in some ways, but also if you like I'm imagining a bamboo grove here, but if you chop this wood down and burn it, then you will get a fire that will burn very quickly and very hot, but only for a short period of time, equals stir fries. Whereas if you chop down this kind of tree in Northern Europe and you try and burn that, then it's going to burn not very hot, but for a really, really long period of time, and therefore stews. And both kinds of food are really delicious, like fast cooked food and slow cooked food. But that's how it developed. Okay, so that's not really to do with this water wet, but it's just because I'm waiting for everyone to gather. And so, in fact, no, we're 8 minutes in. It's time to get going, isn't it? Okay, so do keep throwing, as I provide little clues about water, do keep throwing in your ideas about whether you think water is wet or not. Another quick thing on wetness. This is a gecko. Now, geckos are pretty cool for many reasons. They're really good at holding on to things, and they use forces on an atomic scale to allow them to hold on to surfaces, and that's how they can climb on vertical, like polished glass, and even hang upside down from it, which is pretty amazing. But anyway, one of the mysterious things about geckos, also to do with water, is geckos don't have eyelids. Where are their eyelids? So, because of their lack of eyelids, what do? What's the gecko's strategy for, firstly, staying smart when it goes to the gecko ball, in brackets, it wears a hat, obvi, and also rides a bicycle on a one-wheeled bicycle in one hand to get there. But yeah, how do geckos keep their eyes wet? What do they do? Okay, Roz is saying they lick their eyes, and Angel's saying same. Yeah, they lick their eyes. In fact, Phoebe's saying the same. Okay, you guys know that. I only found that out quite recently, that geckos lick their eyes to keep them wet. I think that's pretty cool. Okay, I had one other interesting thing about water, which is to do with this creature. This is a little albatross. I'm a big fan of albatrosses, or albatri. Albatross. This is a parent albatross feeding a baby albatross. Albatrosses mate for life. They have like lifelong partners, and they live a long time as well. Such big wingspans too, and look at this big fluffy baby that they're feeding. It takes such a long time to raise a baby albatross. It's an absolute task in hand. Anyway, right, so one of the things I was going to quickly ask you about, so while we're on the subject of water, is tides. So do you guys know what is it that causes the tides? So the tide is when the sea comes in and then goes back out, and the sea comes in and goes back out. And if you've been to the beach and built like a sandcastle or something, then you'll know what it's like when it's destroyed by the tide and it cannot be stopped. Oh my god, I saw this terrible video recently of someone who'd been buried on the beach as like just for fun, and then the tide was coming in and they were still buried, and they had to like dig them out as rapidly as possible. It was pretty terrifying. Anyway, okay, so people are saying that the tides, so these tides in the background, are caused by the moon's gravitational pull on the water, but actually they're not entirely caused by the moon. Someone else has said it. Who is it? I saw someone say it. It was 60 said it's also the sun. Okay, so here's the question for you. How much of the tides are because of the moon, and how much of them are because of the sun? What do you guys think? How much of the tides are because of the moon? What's the moon's score in terms of controlling the tides, and what is the sun's score? %98 moon, big on the moon. The real Joe is saying 50% of each. Half and half, share it out, it's fair enough, it's equal. Kieran's saying surely not a lot of the sun. 20 sun, it's about a third. The sun is about a third of the tides. The moon is about 2/3. Yeah, what do you guys think? What do you guys think about tidal power? Sorry, I know we're supposed to be talking about is water wet, but I'm really interested to know what you guys think, because on one of the lives, I think it was actually on Monday, we were talking about carbon and renewable energy sources. What do you guys think about tidal power? And for those who don't know, I'll quickly explain to you how it works. So if you have a coastal area like this, so this is like the edge of the land, and it gradually becomes the sea. So you've got the sea like this. Then at high tide, the sea will rise up to here, and then at low tide, the sea will go down to here. And so tidal power works by building a big wall like this, and then as the tide comes in, it goes through this little tunnel here, and that drives a turbine, and as the turbine spins, that generates electricity. And so the high tide then fills up this pool like that, and then when the tide drops, the water then drains out of the tidal pool, and then that drives the turbine as well. So this is called tidal power. What do you guys think about tidal power? Okay, so Rebecca's saying it's good for us, as it's very reliable. Exactly, it comes every single day. We know we're going to get the tide a couple of times, but it's not very good for environment or habitats. So why do you think that is? Why would it not be good for environment and habitats? And Kieran's saying that tides and ocean currents are so important to keep our global temperature nice and in check. That is really, really true. Yeah, the global currents spinning around the world are absolutely essential for maintaining the right temperatures of the Earth. Okay, so Pose Joe's saying better than fossil fuels, and yeah, that's a really good point. Okay, and Rapsing is saying it creates erosion, destroying habitats. But there's Sam saying it's silly not to harvest such vast amounts of energy. Now, what's really interesting about this about the comments that are coming in is that, although Sam, I guess you won't be able to see the other ones. Guys, if you're on Facebook, just enter in Sam, go to this website, aimhigher.co, if you want to see all the comments, because they're all coming in on there from all the other platforms. But yeah, all the conversation that's going on here is exactly the kind of thing that people are trying to figure out. We're trying to figure out, like, is it, like, how worth it is it if it's also going to be destructive to habitats? How can we create a balance where we're not burning fossil fuels but also not destroying vital natural systems? So Kieran's talking about crabs using the tides to feed, and there are lots of creatures that need the tides going in and out to feed, that depend on being able to come up to the beach and then retreat away from it. And these walls are completely unnatural for them. And the other thing to remember about life in the ocean is that what part of the ocean has the most life? Where is the most life in the ocean? Where is most of the life in the ocean concentrated? LDBR saying poor fish that can't get past. So Lisa's saying surface level and coasts and coral reefs is what everyone else is saying. Exactly, this is it. It's all about the surface, and then it's all about the coasts, and especially the coral reefs on the coast. And so by putting up walls on the coast, you are cutting off, you're making an unnatural barrier in one of the most important areas of the ocean ecosystem. And remember, the ocean is where most of life on Earth is. Who remembers the number for how many? Because we were talking the other day about how I think it was 8 million, or is it 80 million? And I think it's about 8 million viruses from the upper atmosphere rain down on every square meter of Earth every day. So every square meter of ocean, likewise, gets 8 million viruses raining down on it. Or was it 800 million? 800, it was 800 million. Thanks for reminding me, guys. I'm not very good at remembering numbers. Yeah, 800 million viruses rain down on every square meter of the Earth every single day. It's every day. And so as a consequence of that, you get something like 10% of the bacteria in the ocean being killed every single day, which is part of what drives the rapid evolution in the ocean. It's part of the ocean being the center of life. And we think of ourselves here on land as being the center of life, but we're not. The ocean is the center of life. It's where we think life came from, and it's where most of the life is. So by putting up these barriers, it could be a bad thing, but it also could be a good thing. It's a difficult argument to think about, and I just wanted to get you guys thinking about it. Anyway, right, okay, let's go up to this hairdryer. Let's finally start talking about, is water wet or not? Is water wet? So actually, the answer to this question is, let's have one more vote. I want to see where the lay of the land is. Is water wet? Before we start, yes or no? Just put in a Y or an N, and let's get a general yes or no. The no's are pouring in. Everyone's saying no. Nihal's saying yes. Rebecca's saying no. No, because you can't dry it. Exactly. Okay, this is what we're about to talk about. Drying it. So water cannot be dried, whereas wet things can be dried. So this is a hairdryer, and as the hairdryer blows onto a surface, it will dry the surface. And it will dry the surface by removing water from it. By heating it up and also blasting hot air across it. But here is the actual, this is the absolute key point of the argument about is water wet or not, is that actually wetness is not about the water. Wetness is about the surface. So when we describe something as being wet or not, we're actually talking about a surface. So you guys are right in that water actually, the proper answer is no, water is not wet, because water is not a surface. Unless you decide to take a slice through water and say that some of it's the surface and then the water on top is the water, but then that's kind of weird. Yeah, so some people are saying they've looked up the definition of wet and saying that it isn't wet. So, right, before we come back to me explaining why water is not wet, let's first look at this. So this is one of the quite important things that you learn about in science at school, or you might not have got there yet, or also you might not have been told about it in school, but you should have been. So this is a thing called capillary action. Capillary is just like the word for a thin tube. And then action is just the word for something is happening. So what's going on in capillary action? What is the science that is happening here? What do you guys think? So just to talk through what you're seeing. Well, actually, first I'll re-welcome people who are late. Latecomers, thanks for coming. This is an Aim High Live. Ask questions whatever you want, and go here, aimhigh.co, to see the chat and to see what's coming up in later things. I'm going to go back to this now. Okay, so Kieran's saying different pressures, and it's not so much about pressures, although I guess there is a higher pressure in some ways created here. The real Joe hasn't been told it yet, which makes total sense. So Thicko's talking about surface tension of water drawing up the tubes. I'll talk about what surface tension is in a mo. Okay, Daxter's talking about liking the surface versus the air. Right, okay, so there are two key ideas that you need to know about water, and one of them is called adhesion, and the other one is called cohesion. So adhesion, this sounds like a word that a lot of you might know, which is the word adhesive. What is an adhesive? What do you guys think an adhesive is? An adhesive is a glue. It's something sticky. It's something that draws something together. So adhesion is the... Yeah, you guys are... Oh, everyone's so good at this. Adhesion is the effect of bits of water sticking together, holding themselves together and forming bigger droplets. If you think about droplets of water, when you see them and you're pushing them around, they'll stick together into bigger droplets. And that's adhesion. They are sticking to themselves, this stickiness. Right. Oh no, sorry, I've got this oh, this is so embarrassing. I've done this totally the wrong way around. Adhesion, cohesion is when they stick together. I'm so sorry. Right, I'm just going to do adhesion again because I've done this the wrong way around. Okay, so adhesion is the stickiness. So adhesion is talking about how sticky water is when water is sticking to something else. That's what I'm talking about. So you use glue to stick stuff to other things. So adhesion is the effect of, if you have like a surface, like a wooden surface, then water will stick to the surface, right? So imagine that you've got bits of water on a surface. If you were to turn that wooden surface upside down and shake it, then a lot of the water wouldn't fall off because it's glued to the surface. And we call that adhesion. So adhesion is this effect of sticking to other things like glue. Sticking to other things like glue. Sticking to other things like glue. Ooh, make it a bit bigger. There we go. Yeah, adhesion is when you're sticking to other things like glue. Right. Now, the other thing I was talking about is cohesion. So cohesion is the other element that we need to think about that's going on here. Cohesion. So if a group of people are cohesive, what does that mean? What is cohesion? People are asking how old everyone is. The age range on here is so broad. I love that the age range on here is so broad. It's so good. But just go like, okay, what I think about the broad age range on here, because for those who can't see the main chat thread, people are talking about ages on here. One of the things that I think is so brilliant about science and about just like this kind of learning in general is that it's interesting to everyone. It actually doesn't matter how old you are because a lot of this stuff you don't cover in school. And it's just genuinely interesting. That's why I get so excited about this stuff and why I'm explaining it is that like, yeah, it's so good to see that there's like a huge range of people watching this. Anyway, so yeah, there's loads of 14s. There's quite a lot of 20. I know that there are loads of like 18, 20s on here as well. Anyway, so here we go. So cohesion is the effect of water sticking to itself. So that is water forming these droplets where it will stick to itself like this. So when you put these two things together, if you have a very thin tube, then water will climb up a tube. And here's how. I'm going to just zoom out. In fact, let's go down to this lizard for me to explain what's going on. Here's a tube, and in a moment I'm going to talk to you about water climbing up the tube using adhesion and cohesion. But before I do, I just want to ask you another question, which is this. If you've got a surface on which the water is doing mainly adhesion, then is that surface wet or dry? So surface number 1, is it wet or dry? Now surface number 2 is a surface where the water is doing mainly cohesion. So think about the shiny surface of a leaf, or like when water's on a frying pan and it makes droplets. So here it's doing mostly cohesion. Is that surface wet or dry? So that can be surface number 2. So on surface number 1, it's doing mainly adhesion. Is that wet or dry? And on surface number 2, it's doing mainly cohesion. Is that wet or dry? So people are saying 1 is wet and 2 is dry. Exactly. And this is the core of the idea about surfaces being wet or dry. So wet surfaces are ones that water sticks to. So like clothes and towels and bits of wood and stuff like that. Cohesion are surfaces that water does not like to stick to and prefers to stick to itself. So these are the dry surfaces, and that's like your Teflon and like Gore-Tex if you've tried that as well. Oh, someone said 1 is dry. So Leonardo knew, so 1 is not dry because look how much the water is sticking to the surface, like glue, adhesion. So if you were to shake this surface, it would be quite difficult to get the water off. Whereas if you shake a frying pan with water on it, the droplets of water just fly straight off because they actually don't really like sticking to the surface. So that surface is really easily dry. And you might have seen these amazing coatings that you can get that you can cover clothes in, that you can just pour water on the clothes and the water will just go straight off the clothes, completely ignoring them, because you create a non-sticky surface that hates water on your clothes, and that makes your clothes very dry. Okay, so just to quickly explain how the tubes was working next to this lizard, if you've got the water level at the bottom of the tube here, then water likes to stick to stuff, so it will try and stick to the inside of the tube and it will climb up the tube because it likes sticking to it. But then water also likes sticking to itself, which is cohesion. So cohesion means the water sticks to itself and will fill up this gap in the middle because it's sticking to the water at the edges. And that means the water will climb up. But then because the water level's higher, it will then again stick to the edges of the tube. And then because it's sticking to the edges of the tube, more water will then stick to the water here. So it'll do adhesion up the edges and then cohesion to climb on itself. And then more adhesion to climb up the edges, and then more cohesion to climb up itself. And the water climbs up and up the tube until it gets to a point where it's so high that it's gravity that's pulling it back down. And the thinner the tube, the more easily the adhesion and cohesion can work together to pull the water up the tube. And that's why you get this effect here, where very wide tubes, the water climbs up barely at all. You can see that the level there is almost exactly what it was before, just a little more. But very thin tubes, the water will climb up and up and up and up and up the tube. And so, yeah, there you have it. That's one of the important points about science, is that water loves climbing up really thin tubes. And in answer to and just to re-summarize again, in answer to the question, is water wet? Technically, no, because water isn't a surface, and only surfaces can be wet. The surface of this lizard would probably not be very wet, because I think the water would form droplets on the lizard's head instead, which would look nice and would make the lizard's head dry. So tick the little box. I actually can't tick the little box because it's in like an overlay that I can't tick. Wait, can I? Let me try. Maybe there's a way of me ticking it. Draw. Ooh, oh, this might do it. Okay, is water wet? No. Done it. Hooray. So thanks so much for coming, everyone. This has been an Aim High Live, so please go here if you want to see what's coming up next. There will be, in fact, there's one coming up this evening. Here we go. This is what's coming up tonight. Why are some borders straight lines, which is an extension on one that's been done before. So there's more stuff coming tonight and that. And then tomorrow I'm going to do Are Prions Worse Than Viruses? What even is a prion? Find out. And then our advertiser execs The Great Perks of Our Age, which Phil will do tomorrow if he's feeling better. Sorry for those who came to Phil's earlier today about is James and the Giant Peach propaganda, but he was feeling a bit ill, but hopefully he'll be back tomorrow. So yeah, that's what's coming up. Japan Maple saying, wow, it was actually 30 minutes. Yeah, I managed to get it to 30 minutes. And then this was coming up afterwards next week as well. So thanks for coming. Do tell your friends, spread the word, and do follow our socials as well, which are all at Aim High Live for updates and whatnot. Thank you again, and I will see you guys tomorrow for Our Prions Worse Than Viruses. Toodles. Bye-bye.